Let's solve this problem. See, this is what the memory they have given, right? Right now the memory is looking like this. See, can this type of memory structure possible? It is definitely possible. Okay. See, these things, the shaded regions actually denote the processes. Okay, they are actually denoting the processes, and these actually denote the vacant spaces. Vacant spaces we also say that as holes, right? Now, they told that the sequence of requests for blocks of sizes 300, 25, 125, 50 or in KB can be satisfied if we use dash. See, what is meant by satisfying this? See, these are requests which are made from the hard disk into the RAM. Okay, this is the RAM. Now, a 300 KB process is coming into the RAM, followed by 25 KB process is coming into the RAM, followed by 125 KB, followed by 50 KB. Here again we are assuming that it is variable partitioning. Okay, it is variable partitioning. Now the first question I want to ask you is how this type of memory structure is possible. Okay, so let's see that first. See, for what could have happened? See, there are a lot of ways. I'm telling one such way. Okay, initially a 50 KB process should have come. Initially the RAM will be empty. Initially a 50 KB process should have come, and so I occupied it here. Then a 150 KB process came into the RAM. Then a 300 KB process came into the RAM. Then a 350 KB process came into the RAM. Then a 600 KB process came into the RAM. Okay. Now this 150 KB might have completed its execution, and so this has been removed from the RAM. And this 350 KB process and this 350 KB process has completed its execution, and it is removed from the RAM. Okay. In this scenario, the story which I told you for this much time could have made the RAM like this exactly. Okay, this is one such possibility. Obviously, there are a lot of ways. Okay, now tell me, see what is meant by satisfying it. All these requests it should be satisfied means we are able to allocate all these processes. When will we be able to allocate the processes? Only if we have vacant space or holes, right? Let's see this. Let us assume we are using first fit. Okay, and they are also told that this is increasing addresses. What is meant by increasing addresses? The addresses are increasing in this order, which means here the address is 0. Here the address is 1, 2, 3, 4. The addresses are increasing this way. Fine. Let us assume we are using first fit. Okay. Whenever a 300 KB process comes into the RAM, what we will do? We will start scanning the RAM from first in order to find a hole which is big enough to hold this 300 KB process. And we will start here. We cannot occupy it here because 150 KB is less than 300 KB. And so we will come here, and then we are able to find out a 350 KB swag hole, and so we will allocate our process of 300 KB over here. Okay, our 300 KB is over here, and we have a hole of 50 KB over here, right? We have a hole of 50 KB. Now let us assume 25 KB process is coming. Now what we will do, we will again start from the first. Okay, this is what we mean by first fit, and we have occupied this 25 KB over here, and we are left with a space of 125 KB. Okay. Now let us assume at 125 KB process comes into the RAM. Again what we will do, we will occupy this 125 KB over here, right? See, as of now we are having two holes, one hole of size 125, another hole of size 50. Now whenever a 125 KB process comes into the RAM, we will start scanning from the beginning, and then we will occupy at this space. And so here there is no hole, we have a total of 50 KB hole right here. Now whenever a 50 KB process comes into the RAM, we will occupy this 50 KB over here. Okay, so we are able to satisfy all the requests, right? Which means we are able to allocate all these processes. In case if it comes in this order, in case if the order is different, this might not be the case. Okay, we'll see that a bit later. Now, so what I want to tell you is, in case if you are using first fit for this scenario, for this memory structure, and for this order of processes, we are able to satisfy all the requests. Okay. Now let's see what will happen in case if we use best fit. Okay, see what is meant by best fit. In best fit, we will scan the complete RAM, and then we'll find out the smallest hole which is big enough to hold our process, and then we will allocate it, right? Now whenever a 300 KB process comes into the RAM, we will scan the complete RAM, and then we will find out that this is the smallest hole which is big enough to hold the process, and so we will allocate the 300 KB over here. Okay, we are left out with a space of 50 KB over here. Okay, this space is 50 KB. Now whenever a 25 KB process comes into the RAM, we have two holes, one hole of size 150, another hole of size 50, and the smallest hole is 50, which is big enough to hold the process size of 25 kb, and so we will allocate this 25 kb over here, and so we are left with a space of 25. Okay, see, this is allocated. Okay, I'm not showing it here, you can think of it. Okay, all this has been allocated, all this has been allocated. We have now, right now we have two holes, one of size 25 kb, another one of size 150 kb. Okay, now whenever a processor size 125 kb comes into the RAM, what we will do is we have two holes of size 25 and 150. We can occupy only in 150, we cannot occupy in 25, and so we will occupy here. Okay, 125 is done. Right now we have two holes of size 25 kb and 25 kb. Now whenever a process of size 50 kb comes into the RAM, now comes the problem. We cannot allocate this process. Why? Because we don't have 50 kb in contiguous memory addresses, right? Right now we are seeing contiguous allocation. So this is what we exactly mean by external fragmentation. Okay, we have seen it, which means we need to allocate a process of size 50 kb, and also we have a free space in the RAM, which means we have 50 kb of space inside the RAM, but still we are not able to allocate the processes because the 50 kb which we are having are not in contiguous memory addresses, right? They are actually divided. I cannot place 25 over here and 25 over here because then it becomes non-contiguous allocation. So this is what we mean by external fragmentation. So in case if we are using best fit for this memory structure and for this ordering, we will get external fragmentation problem, and so we are not able to actually satisfy all the requests, right? We are able to satisfy 3 requests, but 4th request we are not able to satisfy because it will lead to external fragmentation.